thanks for inviting me to come and talk about the SPAT challenge. So just for curiosity, who knows what SPAT is? A few. And who knows what the SPAT challenge is? About the same group. All right, so I'm going to talk a little bit about what is SPAT, what is the SPAT challenge, why does there need to be a SPAT challenge, and then switch gears a little bit and talk about if we're going to implement SPAT, what messages got to get sent back and forth. That'll make a little more sense when we talk about it. And then we'll talk a little bit about hardware, software, data interfaces. So we'll start up real high level, get down to a few details. Hopefully somewhere in between you'll find something that is worthwhile for you. So what is SPAT? I looked it up in Webster's, and it turned out that wasn't very helpful. So the SPAT we're talking about stands for signal, phase, and timing. And what it is, it's a connected vehicles message that the traffic signal broadcasts to vehicles that are within range of the traffic signals. And it broadcasts it using similar to Wi-Fi. It's called Dedicated Short Range Communications, DSRC. And why do we do it? It enables some applications. And one that you normally think of or associated with SPAT is red light violation warning. So basically, if you're not paying attention and about to drive through a red light, the car should be able to warn you, hopefully in time for you to stop before you get creamed. But there's some other applications also, eco-driving, where maybe the car could tell you if you drive this speed, you won't have to stop at the red lights, or here's how you can drive to minimize fuel and emissions. But then it's also useful for automated vehicles. It's kind of a difficult problem actually for if you got say a Tesla with its video cameras and it's seeing some red lights ahead. Is that the tail lights of the car in front of you, or is that a traffic signal? So actually if the signal's there saying I am a signal, here's what color the light is, that would help the automated vehicles. Yeah, so the SPAT basically is saying here's the indication of all, color of the indications of all the movements at the signalized intersection. So that's basically what is SPAT. So what is the SPAT challenge? So this is a fairly wordy thing that's taken right out of an AASHTO resolution that declared the SPAT challenge. So I think it must have been worded by committee or someone getting paid by the word. But I will read it. So it's, be it resolved that AASHTO is challenging the state and local public sector transportation infrastructure owners and operators to cooperate together to achieve deployment of DSRC infrastructure with SPAT, MAP, and RTCM broadcasts in at least one corridor network, approximately 20 signalized intersections in each of the 50 states by January 2020, referred to as the SPAT challenge. I told you it was wordy. Basically what it's saying is they want, in every state, they would like 20 SPAT-enabled traffic signals in each of the 50 states by 2020. So AASHTO is the American Association of State Highway Transportation Officials, which is made up of all the state DOTs. So basically this is the states challenging themselves to deploy this technology. So why do we need a SPAT challenge? So I'm going to talk about it in a bigger picture of connected and automated vehicles. I like to talk about three dimensions of connected and automated vehicles, and we'll go through these. The first one that I've got highlighted there, the up arrow, is one dimension. That's driving automation and driver assistance. So how many have adaptive cruise control on your car? All right, so that's level one, driving automation. So you set your speed and it runs the gas pedal for you, but if the car in front of you is going slower than you are, you'll slow down, or someone can even put the brake on automatically. That's driving automation. Driver assistance, that's technology in the vehicle. It doesn't take over driving, but may give you warnings or alerts or information to help you drive. Does anybody have like lane departure warning on your car or blind spot warning? So it doesn't take over the car from you, but it hopefully wakes you up if you're about to run over the edge line. So I put those together. Those are technology in the car. They don't really need a challenge for that. It's market driven. All the companies are working really hard trying to come out with this and beat everybody else. It's a standalone thing where if one car company wants to do it, they don't need assistance from any other car companies. They don't have to cooperate with the states. They can just do it. And it's already available, as you said. So this aspect of connected and automated vehicles doesn't need a challenge. The next dimension is vehicle-to-vehicle connectivity. And this is where vehicles communicate electronically with each other. It's not currently happening today, but that would allow cars to avoid crashes with other cars and be able to know where all the cars around them are. NHTSA, the National Highway Traffic Safety Administration, they have authority to regulate safety equipment on new vehicles. And last month in December, they came out with a notice of proposed rulemaking that when it's final, will say that every new car that comes out as some model year will have to broadcast a basic safety message, which is it's going to use DSRC, just like we talked about for the SPAT here, but every car coming out would have to 10 times a second say, I'm here, headed this direction, going this fast, and has to be able to receive those messages. So that's something that's a big part of connected automated vehicles, but we don't need a challenge for that. We don't have to say, car companies, we challenge you to do this because there's a mandate. They'll have to do it, assuming that all gets through the rulemaking process. But then the third dimension is vehicle-to-infrastructure connectivity, and that's where the cars talk to the roadside, like we're talking about with SPAT, or to some server in a back office somewhere. And this one's a lot harder. So there's some institutional complexities. So like for that red light violation warning that we talked about to work, the state and local people that run traffic signals have to do something, and the car people have to do something, and we have to work together, and we're not used to working together. I don't know who to call at Ford if I got questions about what's going to be on their cars. They don't know who to call at MnDOT. So there's some complexities in making that happen. Also, it's not a unilateral thing, like we said with automated driving. Some car company can just go do it. But if Ford decides to say, we're going to put red light violation warning on all our cars, but nobody builds the sign on the traffic signal, it won't work. So they can't just do it. And we could go put stuff on all our traffic signals, but if none of the cars know what to do with it, again, it's no benefit. So it's a little more complicated than the V2V. And NHTSA doesn't have authority to mandate that we do something on a traffic signal like they do on the vehicles. So it gets kind of complicated doing V2I, and there's been people working on this for, I don't know, a decade at least. I've been on committees for connected vehicles. And so it's a little difficult. This is to help illustrate. There won't be a test on this. So this is an excerpt out of the system architecture for red light violation warning. And all I want to point out on here, there's two big boxes. The one on the left is the roadside equipment, and that stuff, for this to work, there has to be an application installed at the traffic signal. And then the box on the right, the vehicle onboard equipment. So there's got to be an application running in the vehicle, and then they have to have all this data going back and forth. So, you can't do it unless both those pieces are there. So it makes it complicated, kind of a standoff. The car people aren't going to start selling red light violation warning if it only works, in 3 places in the United States. And the people that run the traffic signals, don't have a lot of extra money to put this stuff out there if there's no cars to listen to it. So it's a chicken and egg kind of thing. Are we going to go put this stuff out there even though it has no benefit until we get, until the chicken has an egg to go along with it. So what the SPAT challenge does, basically says chicken volunteers to go first. So we're saying let's actually get out there and try and put some of this out. And what it'll do is help demonstrate to the vehicle manufacturers. They call themselves, if you're listening to them talk, they call themselves OEMs, which stands for original equipment manufacturers. It'll show them that the people that run the signals do care about this and are interested in getting our half of it out, maybe to encourage them to make sure that the cars that come out with the V2V are also capable of doing a SPAT message. Also, to help us as MnDOT and other local agencies to get some experience with how this works. We're not used to getting things licensed by the FCC for most of our traffic signal stuff, or how this radio stuff works and where you place antennas so that they work good and stuff. So it'll help us learn since this is something that's coming more down the road. So that's what is SPAT, what is the SPAT challenge, why we need a SPAT challenge. So now I'll go a little farther into this. Suppose we want to take them up on that and start putting SPAT out there. What do we really need to do at the traffic signal? So the first thing, if you're going to implement SPAT, of course, would be SPAT. So I show the SPAT message there. And again, what that is, it's telling what the color of the indications for every movement at the traffic signal currently are. That's the basis of it. The car people would also like us to say also, and how long is that going to be there? Okay, this one movement's green, how long is it going to be green? If you have a downtown grid with pre-timed signals and no detection, you might be able to give them that information, but most of our signals with the state, 0.2 of a second before it's going to change. We didn't know if it was going to change or not, depending on whether a car went over the detector or not. So they also put in there, what's the minimum amount of time it'll be green, or what's the maximum amount of time. And we usually could probably come up with the minimum green time. The maximum, if it's 3 in the morning and there's no cars on the cross street, it might sit in green for an hour, right, on the main line. But they're working with that, and they'll take what we can give them. And since traffic signals, normally the timing or resolution is like 1/10 of a second, you can set your green or your yellows and all reds to the nearest 1/10 of a second. This message would get sent 10 times a second so that it always has the latest information. And where that data would come from, you got to get it out of the traffic signal controller, and we'll maybe touch on that a little bit later. So that's the SPAT message. Now, if that's going to the car, the people in the car want to make sure this is a real message from a real traffic signal and not a computer science student sitting by the side of the road trying to see if they can make every car stop. And so they have a security system that's been set up. The SCMS there is a security credentials management system. The federal government has been working with the car people to try and get this developed because they need it for the vehicle-to-vehicle stuff that NHTSA is mandating. And so the car would need at least periodic communication with this security back end. It uses certificates. You may be familiar with that, just using the web. It had to modify how they do that a little bit because they, unlike on the web, they don't want you to know what car, who owns this car, and they don't want you to be able to track a vehicle, as it moves down. So, but it's basically based on certificates. So this is kind of the basic thing. I know there's been at least some university research projects that have been able to implement SPAT using just this. In fact, probably not using security because they have cars, known and known signals. They can pre-program everything. But in real life, when any car might encounter any traffic signal, this isn't really enough information. They need some more messages. Anybody think of what you might need to know besides what's... Okay, they want a map message. Sometimes it's called GID, which stands for Geometric Intersection Description. And then basically that's a series of GPS lat longs that describe every approach lane to the intersection. And that's so the car, when it's going down, can figure out, oh, I'm in lane number 3, and then it knows which part of the SPAT message to listen to. Because at the same time, the SPAT message is saying it's green for one direction, hopefully it's saying it's red for conflicting directions, right? So the car has to be able to know which piece of that applies to me. That information you can get either survey the intersection, or maybe you got GPS as built when you built the intersection. There's been some research projects trying to figure out, can you build this map message from LiDAR, mobile LiDAR collection or things like that to make it less intensive. That doesn't need to be sent 10 times a second because in general your intersection geometry doesn't change on the 10th of a second. But on the other hand, the vehicle only has a small window of opportunity when it can talk to the traffic signal, and it can't understand the SPAT message until it's gotten a map message. So generally they figure that would get sent about once a second. So then the last one, the car people wanted us to send. This is actually information, GPS differential correction message. The cars in general might not be able to position themselves closely enough to be able to figure out for sure which lane they're in. And it makes a difference if you're in the left turn lane versus the through lane when you're trying to figure out what you listen to from the SPAT message. So it would be tempting to think that this is the real-time correction message, but what it really stands for is Radio Technical Commission for Maritime Services. So there'll be a test on that. Basically, it's a standard that already existed for how you would send out differential corrections. So at the minimum, this is what you would need to do at an intersection if you want to implement SPAT. And so, and you may, if you were paying attention in that really wordy thing I showed from their resolution, it named all three of these messages in there. So, on the other hand, we talked before about the chicken and the egg, and if we do this on our traffic signals, right now there's no cars that could receive this and know what to do about it. And so, what some states have done is decided that where they want to implement this is where there's some other applications that maybe they could do with it that would add some immediate value to it. So, for example, transit signal priority using the DSRC. I know Utah is planning to do this. And so you'd have to add some more messages. The MnDOT's actually looking at doing snowplow priority at signal, so hopefully the snowplows, when they're out plowing, wouldn't have to stop any more than necessary through the signal. Now this one, since the traffic signal is now receiving a message, we'd also probably need a connection back to the security back end, because we also don't want somebody playing, generating false messages to try and make the signal think it's something it's not. And then the last one I put down there, basic safety message, that's the one I said all the cars are eventually going to have to be broadcasting that, and we could listen to that and maybe try and estimate traffic flow parameters, things that we could actually use to help control the traffic signal if we wanted to do that. So those are kind of optional messages, and that's kind of a high-level picture. So one more level down, and this one I won't try to go through all these things because I don't want to take all Brian's time, plus it wouldn't take too long before you'd realize I don't know what I'm talking about. So, I did want to point out a couple of things on here, though. Everything to the right of that dashed vertical line is the stuff that's on the car. Excuse me, to the left, my other right. To the left is the car. Everything to the right is the traffic signal. And between them, the communications between the DSRC and the DSRC, that's what's standardized. So SAE, the Society of Automotive Engineers, has a J2735 that says what's in all those messages. And so you should be able to get anybody's brand of DSRC. It should be able to send those messages to anybody else's, and it'll work. But the back end, the other side of the DSRC is not standardized. So that's going to makes it a little more complicated. So between the traffic signal controller and the DSRC, there really isn't standards as to how that works. And everybody makes their DSRCs a little different. Some of them, you can write your own software and run it on there using some of their software libraries. But then you're stuck with their brand because that's not a standard. It won't work on somebody else's. So that was one thing I wanted to point out. There is a standard over the air between the things. Show a roadside processor there. If the bus or snowplow says, I want to get a green light, you need some software that knows how to take that message and tell the signal controller what to do. So that processor, some people have actually made that software run in the DSRC itself. Like I said, then you're stuck with one brand of DSRC. We're hoping at MnDOT to make that run in a ATC controller with there's a standardized software interface for those that then hopefully it would run on multiple brands of stuff, and eventually could actually run it on the signal controller, the same machine, if you're using ATC standard rates. Let's see, I think the only other thing I wanted to mention, this shows traffic network. A lot of our signals are tied back on a network to our central, and now if we're going to go hang things that look kind of like Wi-Fi out on these, all out in the public, there's going to have to be some serious consideration given to network security. You know, we don't want to open our whole traffic network up to everybody who goes by. So that's it. I got some pictures here. This is a DSRC. You usually put it up on a mast arm, and that's the whole thing all in one box. The communications, the processing, everything. Usually all that comes back is a Ethernet cable, and it's usually powered over Ethernet. This is just to show that it's been done with NEMA controllers and also with 2070 Caltrans kind of controllers. So just a little bit about what we talked about, why it might be valuable. And that's all I have. And I'm going to turn it over to Brian. I think we're going to wait till the end and take questions on all of it.
Thank you, Ray. I'm going to step back here a couple of Ray's slides to borrow one of the slides. What I'm going to talk about is what's going on in kind of the industry where folks are getting ready and getting antsy and starting to deploy some things. General Motors is the first car company that has deployed the DSRC radio in the 2017 model Cadillacs. About 2 years ago, Mary Barra from GM announced, the CEO of GM announced that GM was going to come out with this in the Cadillac. Who here has a Cadillac 2017? Oh, okay. I guess nobody, which is what I thought. So that's why they came out with a mandate here just recently, even though it's proposed rulemaking. So by the year 2021 is when that mandate is going to start proposed to start forcing auto manufacturers throughout any car in the U.S. would have to be manufactured with DSRC radio in the car. So let's fast forward here then to okay, the industry isn't quite ready to wait for that. The SPAT challenge that was put out by AASHTO, the car manufacturers, Ray talked about the chicken and the egg syndrome, so we need to kind of get this thing going. So what Audi now has come up with is a way of delivering the traffic signal information into the cloud. So we're working with TTS, Traffic Technology Services, to introduce this technology to some of the local agencies here that have a central control system. And they're ready to go with this thing. They're doing it now, and all we got to do is get several of the agencies like MnDOT, Hennepin County, Dakota County, Minneapolis, St. Paul, etc., to agree to sign up and use this, do this service and provide it so that the Audi vehicles can, it's just one slice of the market out there, but Audi vehicles will then be able to receive this information. It's the eco-friendly version of what Ray mentioned. It doesn't include the red light running, that sort of thing. So here I've got a video that talks a little bit about it. It's about a 90-second video.
Audi, in mobile connectivity since pioneer.
So there, you can buy a new Audi and then you'll be ready to go. All right. As I mentioned, Traffic Technology Services is currently deploying this. They've actually got it up and running out in Las Vegas, in the Los Angeles area. They're going live, I think, as we speak. There's several of the West Coast cities. They're based out of Portland, Oregon, so they're working there. And then they've selected a few cities along the East Coast, but they've selected the Twin Cities area as a market that is very strong with some of the Audi dealerships. So they want to kind of demonstrate this technology here. So that's why we're helping them. As I mentioned, a key differentiator here is there's no DSRC equipment required, so nothing at the traffic signal cabinet. The actual interface is with the traffic management system. It'll be at the central controller at MnDOT Water's Edge. It'd be at Dakota County's shop, City of Minneapolis, etc. So it requires a system that is highly interconnected with fiber optic communications or other communications to get the data. I mentioned the 2017 models, so they're currently equipped with this technology. What it is again is it's the personal signal assistant that provides current signal status, predicted switch times, when is it going to go from red to green. Actually, what happens here is the data, the map data that Ray had mentioned is obtained ahead of time when we're going through a city, so it's getting that lane by lane version of what's going on within the intersection, and this is a lot of feedback. And so that data is all stored back at Portland, Oregon in their system. Then what they do is they get the real-time data that goes through the prediction, because there is a delay, like a 3 to 4 second delay by the time it goes from the city here system to Portland, Oregon, back to the cellular network, back to the signal. So there's probably about a 4 second delay. So that's why they need to go through this prediction algorithm, and that's kind of the secret sauce that Traffic Technology Services has, working with the simulation software. So they're providing that data. They've got the emergency vehicle preemption and the protect permissive operations. I mentioned the map message that has all the lanes and all that kind of stuff. The communication protocol is exactly the same protocol, the J2735 protocol, that is used within the DSRC communication. Here's kind of just a relationship diagram that shows how each player, where they fall. Like the city, the county, or the state DOT, they provide the traffic information, the map data, as well as then the real-time information. It's a small data feed that provides from each signal when it's about to change. It takes about a week or so for the system to kind of learn the operations. Then there's the partners, all the major traffic controller manufacturers. Traffic Technology Services is working with them to incorporate that information, the software to write an application programming interface, the API. You'll notice IntelliTe's not on here, but they're currently working with IntelliTe on getting that agreement worked out. Then Traffic Technology Services does that prediction algorithm. Then it's delivered to the customers via things like Audi Connect. Kind of the data flows. It shows here basically your ATMS, your traffic management center controller. There's a firewall that then we put in, and that then all flows out to the internet and back through the cellular system back to the driver. I think that is all I have. So, oops. So with that, Ray is going to come up and we're going to take questions.
That audio system there, we know that all with the audio system, you're going to tell the people how much more green time you have left. And we know that everybody isn't really good drivers and so forth. How is it working out that we're not going to get faster than they put?
Brady, that was great. Good question, and that is one of the concerns that people have if they see that they only have 4 seconds that they're going to continue their green, that then they'll attempt to speed up. But
Does that one blank out when you get to the last?
well, it's okay. The flip side of that is when it's counting down, when you're sitting at the stop bar and you have a signal that's in the red phase and it's counting down from 10, 9, 8, 7, 6, 5, it turns off on the dash when it goes from 5, 4, 3. It turns off at about 5 or 4 seconds so that drivers don't rely on that information in order to time the green. Because what they learned through the human factors study is that they have to point that out because they want the drivers then to look up and watch the green light going on. But yeah, that is a concern, and Joe.
Kind of piggybacking on that question, how would an early extend work where you're extending a green time for like the minor approach for the countdown timer, again, just start up or extend and show that, and how does the actual countdown do it?
It works for the typical timing pattern when things are, but if there's something where you've got a signal priority request that comes into the signal through EDP or transit priority, then it goes blank as far as providing the information. So it just runs off the traditional timing. So it notices that if there's a preemption come in, that then it just the information goes away. So it's kind of a driver assist thing, but they're not supposed to rely on it.
So I had kind of a security-based question. With something like signal systems that are transmitting information and they're waiting for information back, how secure is that against, I could just see a future black market where people are saying, hey, download this thing to hack into your car's DSRC to say, hey, I'm a police car, I'm a bus, I'm 26 different cars and sending different information like that.
All right, I'll answer first from the Audi perspective of their system. It's just a one-way feed that's being broadcast out from the city here to Portland, and then it's being comes through the cellular network. So it's just a one-way feed. There's a firewall there. The data just comes out one way. Ray, you want to handle the security management system as far as DSRC?
All right, like I said, I showed on some of my slides that security back-end system. So someone would have to be able to, to be able to get a valid certificate, there's a process to go through. So there's some vetting that way. Also, the SRC is a little bit different than Wi-Fi, and in some of its modes, it would be harder to make something go the wrong way and back into the network. Also, we still need to figure that out.
What's the range of the signal? Because if they're closely spaced signals in downtown, this indication it's showing, is it for the next signal coming up, or how do you know?
For the DSRC, the range is supposed to be about 300 meters, about 1,000 feet. But a lot of it, I showed things mounted up on the mast arm, and getting the antennas in the right place makes a big difference. I've heard somewhere they could get, a quarter mile one way and only 30 feet the other direction if they didn't do it right. But it will also be saying which signal it is. So even if the vehicle is able to hear from 5 signals at once, it will know which one is which. And then based on that map message, it should know what of that stuff it should be listening to. If you guys have anything on that. Anybody else?
All right, well, let's thank our speakers one more time. All right, that's our conclusion of the meeting, I think, unless Mike, you had any other announcements?
The award winners could stay here for some pictures. We'll get some good writer shots.
All right, thanks again for coming.
Actual speakers as opposed to.
Yeah.
Thanks for helping set up.
No problem. Hoping the webinar worked good. I see if they did.